Hello, you're welcome to this lesson. In this video, you're going to learn how to find the differential of multivariable functions. Let's have a function z, which is equal to f of what? X, y. Okay, z is a function of what? X and y. Okay, so if you're asked to find the differential of this function here, which will be dz, this will be equal to fx dx, okay, plus fy dy, or you can see that df, okay, will be equal to fx dx, okay, plus fy dy. Okay, they are all the same expressions. So what this means here is that if you have a function of x and y, you can differentiate with respect to x and then differentiate with respect to y, and then after that we add. So let's take an example. So let's say you have z to be equal to e to the power x squared, okay, plus y squared than 2x, okay, than 2x. So let's say you have this function and then you've been asked to find the differential, which is what? Dz. So what you do is that you're going to differentiate this whole function here with respect to what? X first. Okay, so let's look at that. So you're going to have fx, right? So let's look at that. So for fx, I'm going to consider this as a product, right? So we have e to the power x squared plus y squared multiplying tan of what? 2x. So first of all, I'm going to differentiate this first term here and then keep tan 2x as a constant. So let's look at that. So I'm differentiating e to the power x squared plus what? Y squared. So I'm going to have e to the power x squared plus what? Y squared. Then from here, I'll multiply by the derivative of what? The expression inside with respect to what? X. So you see that you will have x squared plus what? Y squared, right? So in differentiating this, I'm going to have 2x plus what? 0. This term here becomes a constant since you are differentiating with respect to what? X, so it will become 0. So we're going to multiply by what? 2x. Okay, so by 2x, then all this by what? Tan of what? 2x. Okay, then from here, we are going to keep e to the power x squared plus y squared. Okay, and then we multiply by the derivative of what? Tan 2x. Okay, differentiating tan 2x will give us sec squared 2x. So we are going to have sec squared 2x. Okay, then from there we multiply by the derivative of what? 2x, which will be what? 2. So now let's simplify this. We're going to have fx to be equal to 2x, okay, 2x multiplying e to the power x squared plus y squared, okay, tan of 2x, okay, tan of 2x, then plus, let me bring the sec squared, so that will be 2 sec squared 2x, okay, multiplying e to the power x squared plus y squared. Okay, so this is what you have. So what I'll do is that I'm going to bring a square bracket and then I'll put the x here. So that was for the first term. Okay, so now let's do the same for the second term. Okay, so now let's solve for the second term, which is what? Fy. Okay, so now you're going to differentiate the z function with respect to what? Y. Okay, so let's look at that. So I have the first term here, e to the power x squared plus y squared multiplying tan 2x. So I'm going to apply product rule here. So I'm going to differentiate this first and now keep tan 2x. So I'm going to have e to the power x squared plus y squared multiplying the derivative of what we have inside. So for that we have x squared plus what? Y squared. Okay, and then differentiating this with respect to y will give us 0 plus what? 2y. Okay, so let's take note of that. So I'm going to multiply by 2y. Okay, and then multiply by what? Tan 2x, which we kept constant. Then now let's keep e to the power x squared plus y squared as a constant. Okay, let's keep that as a constant. So now let's differentiate tan 2x. Okay, let's differentiate tan 2x. So that would be sec squared 2x. Sec squared what? 2x. And then that will be multiplying the derivative of what? The expression inside. Okay, but you see that the expression inside doesn't have any y in it. So therefore the derivative will be what? 0. So all this term here becomes 0. So you're going to have fy to be, let me write 2y first. Okay, so I'm going to have 2y e to the power x squared plus what? Y squared multiplying tan of what? 2x. Okay, multiplying tan of what? 2x. Then you can bring our dy. So we are going to have dz to be the sum of what? Fy and then fx. Okay, so you're going to have, then write this, you're going to have 2x e to the power x squared plus y squared. Okay, multiplying tan of 2x. Okay, then plus 2 sec squared 2x. Okay, multiplying e to the power x squared plus y squared. Then you bring the dx to show that you differentiated with respect to what? X. Okay, then we have plus. Then let's write down 2y e to the power x squared plus y squared tan of what? 2x. Okay, then let's bring our dy. So this will be the answer for the differential of the function that was